Okay, example 1 is really asking you to solve the same exact equation that you're asked to solve in example 2. It's just using a different method. In example 1, we relied on the graphing calculator and we used the calculate functions and used the zero functions of the calculator, setting a left bound and a right bound and letting the calculator do the work for us. Now we're going to use something called the location principle, and it relies on a table of values. I personally think this method is easier, but I do want to go through the concept of the location principle with you. Basically, it just tells us that if P of A is a negative number and P of B is a positive number, then somewhere between this value of A and B, a zero occurred or an x-intercept occurred. So that's what we're going to do. We're going to go to the table of values and look for where the y-coordinates go from being negative to being positive, between which two values of x. And or where do they go from being positive to being negative, between which two values of x. So let's take a look at the table of values. Okay, so using the table of values, hit second graph to get to the table of values first of all. And I can see that when x is negative 1, y is positive 5. And when x is 0, y is positive 2. However, when x is 1, y is negative 3. So somewhere between where x equals 0 and positive 1, that y-coordinate went from being positive to negative, so it crossed the x-axis. And as you recall, one of our x-intercepts was between 0 and 1. I can change the setting so that I can see a little closer and zoom in on that by hitting the table set. Right now the table is starting, not the graph, the table is starting at negative 1 and it's going up in increments of 1. I can change that by going to the table, second window, to start at negative 1, but change it so that it goes up in increments of 0.1. And now, I hit enter. Now when I look at the table of values, x starts at negative 1 and it goes up in increments of 0.1. Keep adding 0.1. And I can see that when x is all these numbers, the y-coordinates are positive. So the y-coordinate goes from being positive to negative between 0.3 and 0.4. And as you recall, one of our x-intercepts was between 0.3 and 0.4. When x was 0.38, y was 0. So one of the zeros does occur between 0.3 and 0.4. And to find some more x-intercepts, I just keep scrolling. I know there's 3 of them. And using the table of values, I just keep scrolling to see where the y-coordinates go from being negative and change signs. Where do the y-coordinates change signs and become positive? And I can see that happened right here between where x is 2.6 and where x is 2.7. Y-coordinates went from being negative to positive, so there is another 0 that occurs between those two values. And if we wanted to find the third 0, remember that was where x equals negative 2. I saw that by looking at the graph, but I could just keep scrolling. It's a cubic function. I know there's going to be 3 zeros, and I can see that when x is negative 2, that y is exactly 0. And just a little word of advice that whenever you've changed the table settings on your calculator, the next time you go to use it, it might be not what you want. So I would hit the table setting again, hit second window, and change that back to a whole number to start at, like maybe, I don't know, 1 or 2 or 3, and then change it so that it doesn't go up in increments of 0.1. but whole numbers, and then you'll have something that looks more familiar to you the next time you look at the table. Okay, so to do example 3, just factoring by grouping, I think you guys are familiar with this one. There's 2 terms here and 2 terms here, and I'm going to find the greatest common factor in each pair of terms. In the first set of terms, I can see that my greatest common factor is x squared, so I'm going to write this as x squared. Can't do exponents on Jamboard, but you know what it looks like. And then in the parentheses, I'll have x plus 5. And in the next set of parentheses, I can see that my greatest common factor here is negative 4. So I'm going to put negative 4 outside the parentheses. And inside the parentheses, I'll have x plus 5 again. Go back in there. And that's equal to 0. So now I'm going to rewrite this as x squared minus 4 in one set of parentheses. And in the other set of parentheses, I'm going to have the x plus 5 that shows up twice. And again, set that equal to 0. Now, I don't know if you realize it, but this is the difference of two perfect squares. So I can factor x squared minus 4 into x plus 2 times x minus 2. And then I still have the factor of x plus 5 and set that equal to 0. So now it's really easy. I have three factors multiplied together give me 0. So if the first factor equals 0, if x plus 2 equals 0, then I know that x equals negative 2. And if it's the second factor that equals 0, x minus 2, if x minus 2 equals 0, then I know that x is going to equal positive 2. Or if it's the third factor that's 0, then x is going to equal negative 5. So those are my three zeros. The three zeros are x equals 2, x equals negative 2, x equals 2, and the third zero of this function would be where x is equal to negative 5. Okay, to do example 4, I'm just going to calculate the difference quotient for this particular function right here. And remember how we did it using linear functions. This is not a linear function, so I won't end up with just a number or the slope here. What I did was I replaced every x in the function with, first we replaced it with x plus h. So what I'll have here, I'll make this a little bigger. We'll have f of x plus h, in this case, replace this x with x plus h, and replace this x with x plus h. So I'll have x plus h squared. I have to square that binomial. And then I'm going to subtract from it 3x plus h. What I did was I replaced both of these x's with x plus h squared minus 3 times x plus h. And then from that, don't forget that I need to subtract f of x. So I'm going to need to subtract a two-term expression, x squared minus 3x. So let's start simplifying. Well, x plus h quantity squared, remember this is a binomial squared, so I'm going to square the first, square the last, so that's x squared plus h squared, and then double the product of the two, so double x times h, so 2xh. And the next thing I'm going to do from that is I'm going to subtract 3x and subtract 3h. So I'm distributing the negative 3. So minus 3x and then minus 3h. I may move this over a little bit. Okay, and now from that I'm going to subtract an x squared, and I'm also going to subtract negative 3x. So taking away a negative 3x, it's like I'm distributing this negative sign. I'm adding 3x. So let's take a look at what cancels. Well, I can see that this x squared positive cancels out this negative x squared. I can also see that this negative 3x cancels out this positive 3x. And that leaves me with three terms. And the three terms that I'm going to be left with are, let me type this a little better, it's going to be h squared plus 2xh. And then the last term is minus 3h. And the last thing I need to do, because this is just the numerator, f of x plus h minus f of x, this is just the numerator, divide everything by h. So let's see what that's going to look like. Well, when I divide the first term by h times h over h squared over h, that's just h. And then when I divide 2xh divided by h, the h's are going to cancel. I'm just left with plus 2x. And the last term, negative 3h over h, the h's cancel, and I'm left with just negative 3. So the quotient, the difference quotient for this function ends up being h plus 2x minus 3.